A2 Statistics, Chapter 1, Regression, Correlation, and Hypothesis Testing. Lesson 1, Exponential Models. You can use regression lines to model linear relationships between two variables. Sometimes the data might show a pattern that may not fit a linear model. You can use logarithms and coding to examine trends in nonlinear data. If data can be modeled as y equals ax to the power of n, you can use the coding y is equal to log y and x is equal to log x to get a linear relationship. In statistics, the log of a number usually represents the log with base 10 of that number. If y is equal to ax to the power of n for constants a and n, then taking logs of both sides gives us log of y is equal to log a plus n log x. If we use the coding I just said, where y is equal to log y and x is equal to log x, we get y is equal to log a plus nx, and this is just a straight line with a gradient of n and a y-intercept of log a. For data with an exponential relationship, y is equal to ab to the power of x, you need to code the data now where y is equal to log y, but now x is just equal to x to get a linear relationship. If y is equal to kb to the power of x, then again taking log of both sides, we get log y is equal to log k plus x log b. And if we use the coding y equals log y and x equals x, we get the straight line y equals log k plus x log b, where the gradient will be log b and the y-intercept will be log k. Let's do an example. The table shows the data collected on the temperature in degrees Celsius of a colony of bacteria and its growth rate. The data is then coded with variable changes x is equal to t and y is equal to log of g. The regression line of y on x is found as y is equal to minus 0.2215 plus 0.0792x. Part A. A student says that the constant minus 0.2215 in the regression line means the colony is shrinking when the temperature is 0 degrees. Explain why this is wrong. And Part B. Given g is equal to kb to the power of t, where k and b are constants, find k and b. For Part A, when t is 0, x is also 0. So according to the model, y is equal to minus 0.2215. And we know y is just log g. So log g is equal to minus 0.2215. And then we can find g by making 10 to the power of both sides. So we get g is equal to 10 to the power minus 0.2215, which is about 0.60023 SF. And this is bigger than 0. So the growth rate is positive, and so the colony is not shrinking. Part B, we need to substitute back x is equal to t and y is equal to log g. We get log of g is equal to minus 0.2215 plus 0.0792 t. Now, to get rid of the log, we need to raise both sides to about 10. So g is equal to 10 to the power of minus 0.2215 plus 0.0792t. And because this is a plus, that means that we can multiply them out. So g is equal to 10 to the minus 0.2215 times 10 to the power of 0.0792t. And because this is multiplied, we can rewrite this as 10 to the power of 0.0792 all to the power of t. And then g is equal, this from the first part we already got is 0.600, and then this evaluates to about 1.20 to the power of t, both of them to 3 SF. And so therefore, your k is equal to 0.600, and your b is equal to 1.20. And that's about it.